this video is to help explain how to use graduated cylinders. So best I could do to get some marks on here, just made this picture up real quick, but this one on the far left is supposed to represent my 100 milliliter graduated cylinder. It doesn't really look like this. The 10 would be a big line, the 20 would be a big line, there'd be like a slightly larger line at the 15, everything else would be normal size, smaller line. But at the end of the day, when you're reading this thing, each mark is 1 milliliter. So from 10 up to 20, I passed the 15, 16, so I know that this measurement is at least 16. It's between 16 and 17. And I'm going to estimate in this case that maybe that last digit is a 7. Right? So understanding, like if you can imagine your own halfway mark here, and then think about it, is that a 6? Is it a 7? Because even after adding that, just that little line in my head, I might think now that it's a 16.6, right? That difference, though, is negligible. This estimated digit is not supposed to be the same from one person to the next, because you will look at that measurement slightly differently. And without that actual line there to tell you where half is, there's no way that you would know exactly what it is. You're just making a good estimate. Otherwise, if I had that same amount of liquid over here in a 50 milliliter graduated cylinder, I'd have kind of the same marks, just the halves are included. So I added the little kind of bluish lines for half marks. The real graduated cylinder wouldn't quite look like this. It would be from like every 5 milliliters would be a big mark, and then all the other lines are the same size, right? Except for this half, like 17.5, would have been a little bit longer, and that just actually is more confusing, right? Not a real big fan of how they made those graduated cylinders. This is that slightly longer line in the middle, but that's just showing you halfway between 15 and 20, and it's not necessarily that useful. But what happens is that now that I can see that, okay, this is 15, this would be 16 because it's 16 and a half still. It's the same marks as I had over here, 15, 16, right? 17. I know that that liquid level is between 16 and 17, but the difference being I can see the half. So maybe I would more accurately predict that it's going to be a 16.4 because it's not quite to the half, and just get a little bit better measurement. The tool is actually better and more precise, and you can get a more accurate answer. But you do have to know how to read it. You have to see those halves and know what to do from there. The 10 milliliter graduated cylinder, a lot like the 100 milliliter graduated cylinder, but because you are seeing tenths instead of ones, right? Since I'm going from 9 to 10 and all the individual lines are 0.1, 0.2, 0.3, I know I got all the way to 0.4 here. So I know that my measurement is going to be 9.4, but then I estimate one more digit. So I'm going to estimate 100th, and since it's just above that 0.4 line, I might think about calling it a 1 or a 2. We were talking in class about how technically every line has a width, right? This line for the 0.4 is probably wider than what I've represented it with on this screen. And if you're touching that line, it has to be at the bottom of that line for it to actually be a 0. So we talked about how the 1 and the 2 oftentimes are part of the line itself. So just because the meniscus is touching the line, if it's touching the top of the line, it might not be a 0. If it's touching the bottom of the line, it's definitely a 0. Because it's the same rules. We don't read the top of the meniscus, we read the bottom.